Hello there, my name is Neil Josing, and today we are going to be discussing about four types of techniques of integration. So first we have U substitution. Next, integration by parts. Integration by parts. Next is partial fraction. Trigonometric substitution first. We are going to be going by order. Metric. Substitution, and lastly is our partial fraction. But after this we will also discuss about multiple integration, or our double integration, double integral, and triple integrals. So first off, we have U substitution first. You can remember this original formula for our U substitution. For this, integral of U raised to n du. This is our power formula. It is equals to U raised to n added by 1. The exponent is added by 1, and then our exponent added by 1 will bring down as our denominator, which is also n plus 1. And don't forget the constant of integration. Next is the integral of d over u. Or it is 1 over u, right? 1 over u du. That is just equals to ln absolute value u plus c. Next is then e raised to u, and then add the constant of integration. Next is the integral of a u with the constant denoted by a du equals to a raised to u all over ln a plus c. So first off, we are going to have an example. Let's see, an example will be the integral of du all over square root of x multiplied by 1 plus square root of x. Now we will look for a term or a variable that we will use as or for as our u. Yes, as our u. And in this case we will use 1 plus square root of x. Next, we will look for the derivative of u, or the derivative of 1 plus square root of x. Since the derivative of 1 is just equals to 0, we'll have the derivative of square root of x, that is equals to 1 over 2 square root of x dx. Now if you can see 1 over square root of x dx, we have that here, right? And our u is 1 plus square root of x, so we can first ignore that. We're going to focus on our du. Since it's missing a 2, we will add a 2, and since 2 over 2 is just equals to 1, If we multiply 1 to the whole integral, it will stay the same. So if we add the 2 as our numerator, then there will be also 2 in the denominator right here. So if you can see, we now have our du, our u and our du. So copy 2 and then just substitute du and u. So if you remember from the previous, our general formula here is the same as that. So this equals to ln absolute value u plus constant of integration. Now we are going to revert u back to its original. That is equals to ln absolute value 1 plus square root of x plus c, and that is our final answer. Okay, next problem, we have the integral of e raised to 2x all over e raised to 2x plus 3, so dx. So same as our previous example, we will look for a term or a variable that we will use as our u, and in this case it is e raised to 2x plus 3. So look for the derivative of u, that is 2e2x dx, and if you can see, we are missing a 2. We have our u here, but we are missing a 2 since there's already e2x dx on top. So we add 2, and since we need a numerator, we need a 2 on the numerator, we are going to first add a 2 on the denominator, so we can have a 2 on the numerator all over e2x plus 3. Forget that dx. Now if you see, this is already identical to du, so substitute 1/2 integral of du over u. Now if you can see, it is the same formula from the previous example, so is ln of value plus c. Now lastly, we revert u back to its original, ln e2x plus 3 plus c, and that is our final answer. That is our u substitution. Next is our integration by parts. Now in integration by parts, let's see here, we have that d equals to uv, d times derivative of uv is equals to u dv plus v du, right? Now if we transpose u dv to the other side, if we transpose v du to the other side, we will have u dv equals to d uv, the derivative of uv plus v du. And next we will add the integral sign here to look for the integral. So we will have the integral of u dv equals to the integral sign, and the differential will cancel out each other. So we will have uv plus integral of v du. It's minus, sorry, since we transposed it, it's going to be minus, has to be negative, so it's minus the integral of v du. There, that is our formula for integration by parts. And next To better understand it, we will use an example. We have the integral of x squared times e raised to negative x dx. Now, as you can see from here, we have the u and the dv, but in here we need the uv and the du. So what we look for is our u, du, v, and dv. And since u and dv are already available in our integrand, we will look for the du and the v, right? So first add the u, du, v, and dv here. And next is we would use x squared as our u, and its derivative is 2x dx. For dv is e raised to negative x dx. If we find its integral, that is negative e raised to negative x. So plug in using uv minus the integral of v du. Plug in all values needed, that is negative x squared e raised to negative x minus the integral of negative e raised to negative x 2x dx. Okay, next we bring out the negative sign and the constant 2, that is now become positive, and positive 2 integral of e raised to negative x dx. this will become, this will just be 3, and this will just be 2ex. So it's the same as, so this is just the same as the value x squared minus a squared, and that is equals to substitution of x equals to a secant theta, right? So since x is equals to a secant theta, but in this case it's going to be 2ex equals to 3 secant theta. Now what we're going to be doing next is look for its derivative, right? And its derivative is 3 secant theta tangent theta d theta. And we also need to transpose this here, and since it is equal to 3 secant theta, we can just put in 3 secant theta tangent theta d theta is equals to 3 secant theta. So our dx, if we cancel out both of these terms here, our dx is equals to tangent theta d theta. There. So substitute our x and dx, that is tangent theta d theta all over square root of nine. Since it is squared here, we also squared 3 secant theta, that is 9 secant squared theta minus 9. So what we will do first is we bring out 9 here, so that we equal to 9 times secant squared theta minus 1. And secant squared theta is equals to tangent squared theta. So if we bring out 9, if we find the square root of 9, that is 3, and the square root of tangent squared theta is tangent theta. So we cancel out tangent and tangent, and what we have left is just d theta over 3, integral of d theta over 3, and d theta over the integral of d theta over 3 is just 1/3 theta plus c. Now one more crucial factor we need to do in trigonometric substitution is we substitute theta using what you have here. So I will put it here, x equals to a secant theta, right? Or in this case it's 2ex equals to 3 secant theta. So we divide both sides by 3, that is equals to secant theta equals to 2ex over 3, and we also need to transpose secant to the other side, so that is equals to secant arc secant equals to our theta rather is equals to arc secant 2ex over 3, and that is our theta. So substitute theta, that is 1/3 arc secant 2 e raised to x over 3. plus c, and that is our final answer. That is for the integral of dx over 4 square root of 4e raised to 2x minus 9. Another example, we will use integral of 1 over x squared square root of x squared minus 9 dx. So from here we can see that it is x squared minus a squared, which is equals to a second squared. So x is equals to, this is a squared, so a is 3 second theta, and the derivative of 3 second theta is 3 second theta tangent theta d theta, right? So substitute x and dx, that is integral of 1 of it. If we put the dx on top, that is 3 second theta tangent theta d theta all over 3 second theta, or because it is squared, you can just directly square it, second squared, and square root of 9 second squared theta minus 9. So just like before, bring out 9, that is equals to 9 times second squared theta minus 1, and second squared theta minus 1 from the trigonometric identities, that is equals to tangent squared theta. So the square root of 9 and tangent squared theta is 3 times, that is 3 tangent theta, right? So integral of 3 second theta tangent theta d theta all over 9 second squared theta multiplied by 3 tangent theta. So we cancel out tangent theta and second theta. So multiply 9 and 3, but divide by 3 also. So cancel out 3 and 3 here. What we have left is integral of d theta over 9 second theta. There. And the integral of 9 second theta, first we will bring out 9, 1 over 9, and then the integral of, using the trigonometric identities, 1 over second theta is equals to cosine theta d theta, and the integral of cosine theta is sine theta plus c. There. But since this is a trigonometric substitution, we will look for the substitute of sine theta, and from here we have, if we divide both sides by 3, we have second theta equals to x over 3. Using Pythagorean theorem, we have a right triangle here. Yeah. Second theta is 1 over cosine theta in the trigonometric identities, yeah, right? And cosine is equals to adjacent over hypotenuse. But since it's second squared, it is equals to hypotenuse over adjacent. So this is hypotenuse, x is hypotenuse, and 3 is adjacent. And if but we are looking at theta, and in SOHCAHTOA, sine theta is opposite over hypotenuse, so that is equals to, and so this is our opposite and this is our hypotenuse, so sine theta is equals to square root of x squared minus 9 all over x, and we substitute sine theta over there. It is equals to 1 over 9 multiplied by square root of x squared minus 9 all over x plus c, and that is our final answer. we find a limit so we can substitute it with x. And to find the limit, we will look for a number that will result, that if we add it to 1, it will result to 0. So in this case it is -1, right? So -1. And if we substitute it to x, it will be equal to 4 over -1 minus 2. Now simplify it. To simplify it, it will be equal to -4 over 3. This time for our b. Because in partial fraction, what we need to do is look for our a, our b, our c. In this case, we will look for their variable, their value. And as you can see, our a is -4 thirds. This time we are going to look for b, since it only has a and b here. So b is equals to, copy the numerator, 4 over, using the cover up method, cover up x minus 2 here and x minus 2 here. What remains is x plus 1. So we put in x plus 1. Now we will need a limit to substitute x with. To find the limit, we'll look for a number that if you add it to -2 here, it will result to 0. So in this case it's 2. So substitute x with 2. 4 over 2 plus 1, that is equals to 4 thirds. Now what we're going to do next is substitute a and b with these two values with the same equation as this. So integral of -4 over 3 over x plus 1 plus 4 thirds all over x minus 2 dx. Now we will integrate it. First, bring out -4 thirds here, -4 thirds, and then x plus 1 is just ln x plus 1 plus, bring out 4 thirds, constant 4 thirds, and then ln x minus 2 plus the constant of integration. That is our final answer for this partial fraction here. So another scenario would be something like this, where 2 is something like this, n over x squared multiplied by x minus 1 cubed. So since there are exponents on one, we will repeat it. So plus 2 reaches its exponent plus c over x minus 1 plus d over x minus 1 squared plus e . I'm sorry, this is b. Now we will also look for the value of each of these letters. X dx all over x plus 1 x plus 2 squared equal 2, and then c over x plus 2 squared. If we substitute negative 1 with x, it will be negative 1 over negative 1 plus 2 squared. Simplify this, it will be equal to negative 1. For letter B, once again copy x and then cover up x plus 2 and x plus 2 here, but there's a squared, so we'll have x plus 1 times x plus 2. Since we can only cover up one of the square of x plus 2. Now let's find the limit. We can use that. If you add it to 2, it will result into 0, so it is negative 2. Substitute negative 2, it will become equal to negative 2 all over negative 2 plus 1 times negative 2 plus 2. Now if you can see, this is just indefinite. We will use the substitution method, and right now I will show you how to do the substitution method. So first we multiply both sides with x plus 1 x plus 2 squared. 1 times x plus 2 squared, so this will all cancel out, and if we multiply it, it is then divided by their denominator. So what we have left here is x is equals to a over x plus 2 squared plus b over x plus 1 x plus 2. No, I'm sorry, this is wrong. It's supposed to be a over a times x plus 2 squared plus b times x plus 1 times x plus 2 plus c times x plus 1. And that is our standard form for the substitution method. So next is we will substitute a here. This is negative 1, right? So for that, we can also get the value of c from the cover-up method, right? So first let us get the c here, x over x plus 1. And if we to get something, we need something to, so that it will result to 0. So this is also negative 2. So substitute negative 2 with x. This equals to 2. So from this standard form for the substitution method, a is negative 1 and 2 is c is 2. So this will make it easier. So negative x plus 2 squared plus b x plus 1 x plus 2 plus 2x plus 2. There we go. So next is, this is our substitution method or the coefficient method. As this is our substitution method, so if x is equals to 0, that is, substitute it to all x here, as 0 equals to negative 0 plus 2 squared plus b squared plus 1, 0 plus 1, 0 plus 2 plus 2 times 0 plus 2. So this will cancel out. This will become 2 here, and this will become negative 4. So if we transpose all the constant and then divide it by 2, it will become b equals to 4 minus 2 over 2, which is equals to 1. And that is our b. So next is, we substitute. You can see here, there, let's just move that. So let's substitute. A is negative 1, right? Negative 1 over x plus 1 plus b is equals to 1 x plus 2 plus c is equals to 2 over x plus 2 squared dx. Now this we will use the sum rule to get the integral of each of these terms here. This is negative ln over x plus 1. There should be no integral sign over there now, since this is the integration. Negative ln x plus 1 plus ln x plus 2 minus 2 over x plus 1. If you use the use of substitution here, this is, or the power formula, this will become negative 2 here, and then if you add a 1, it will become negative 1. Bring it down again, it's just 1 here, plus c, and this is our final answer. Another scenario here. we have scenario 3 is, let's see, it is n over ax squared plus bx plus c equals to we will look for using partial fraction b x squared plus 9, that is 2x all over x squared plus 9 plus c over, without the derivative, just add x. So in this case, a is equals to 2/5, b is equals to -1/5, and c is equals to -2/5. Now what we'll do, this is our final answer. Okay, next we have double integral here. So first is we have 3 integral from 1 to 3, and the integral from 2 to 4 here. 9x cubed y squared dy dx. Now to better understand double integral, it's just integration, but we're doing it twice. So there are two methods. We integrate it by like this. We start with the middle one, or we integrate it from this original equation here. We will integrate it like this. Dx multiplied by the integral from 2 to 4 y squared dy. So these are two ways to integrate multiple integration, but we will use the standard integration. This is much faster to learn. So since we start from the middle, we have the integral from 2 to 4 9x cubed y squared dy, and since this is dy here, we will only integrate y squared, and we can consider the other variables such as x or z as constant. So 9x cubed, and the integral of y squared is y cubed over 3, with limits from 2 to 4 dx. Next is we substitute 2 and 4 to y, and then we cancel out 9 and 3 here. So 3x cubed 4 cubed minus 2 cubed dx, that is equals to 168x cubed dx. Next is, since this is now dx, we will look for the integral of x cubed. 168 is a constant, so we bring that out, and the integral of x cubed is x raised to -4 x raised to 4 over 4, with limits from 1 to 3. Now we divide 168 by 4, that is equals to for 2 x raised to 4 with limits from 1 to 3. Now substitute 3 and 1 to x, that is 42 times 3 raised to 4 minus 1 raised to 4, that is equals to 3,360. That is our final answer. That is one way to better understand double integration. Another example is limit from 11 to 14, integral of with limits of from 7 to 10, x squared plus 4y dy dx. Now, since dy is the is in the middle, we will only integrate 4y, and we will consider x squared as a constant. So 14, 11, bring out x squared. Since x squared is constant, we will add a y here, plus 4y. The integral of 4y is 4y squared over 2, but if we divide 4 over 2, that is 2y squared with limits from 10 to 7 dx. Now we substitute 10 and 7 to y, that is 3x squared plus 102 dx. Next is we find the integral using the dx here. Find the integral of x, that is 3x cubed over 3. If you cancel out 3 and 3, that is just x cubed plus 102x with limits from 11 to 14. Substitute 14 and 11, that is 14 minus 14 cubed plus 102 14 minus 11 cubed plus 102 11, and our final answer here is 1719. And that is our final answer. Another example for multiple. Let's find the integral. We will start from the center, so dx, we will consider the others as constant. So just bring out y squared and z cubed. X, so x is x squared over 2 with limits from 0 to 1 dy over dy dz. So equals to 0 to 3, 0 to 2, y squared z cubed. Substitute 0 and 1 to x squared over 2, that is just 1/2 dy dz. So next is we substitute, we will find integral with dy now. So 0 3 z cubed over 2, just bring out the constants, and then the integral of y squared is y cubed over 3 from 0 to 2 dz. Now substitute 0 and 2 to y that is c cubed over 3 over 2 8 over 3 dz equals to, this equals to 8 over 6, and then the integral of z is z raised to 4 over 4 here. With limits from 0 to 3 is equals to, simplify, it is 1/3, and then if we substitute z 3 to z, it is 3 raised to 4. So next is, it is now 81 over 3. So so the final answer is 27. That is our final answer for this equation. Another example is integral of pi over 2 0 z 0 y 0. So for x sine z dx dy dz, this equals to pi over 2 0 pi over z over 0 from 0 to z, for y sine z, since dx is left here, we will wait, forgot the y here. We will find integral of x, that is x squared over 2 with limits from 0 to y dy dz. Next is we substitute y to x, that is equals to pi over 2 0 z 0 4y sine z. Let's cancel out 2 and 4, that is 2y cubed sine z dy dz. Since x is substituted, multiply it to y here, it becomes y cubed. Next is integral of pi over 2. Next is dy. So we will look for the integral of y raised to 4, that is 2 sine z y raised to 4 over 4 with limits from 0 to z dz. Now bring out, cancel out 2 and 4 here, we bring out the constant, that is 1/2 pi over 2 0 with z, that is z raised to 4 sine z, apply z raised to 4 here dz. So what we're going to do next is, this is integration by parts, but to make it faster we will just bring it all out here. Negative z raised to 4 cosine z plus 4z raised to cube sine z plus 12 raised to z raised to 2 cosine z minus 24 z sine z minus 24 cosine z raised with limits from pi over 2, 0. Now if we substitute z with pi over 2, all of it, it will be equal to 0.9. And that is all for this video.